Open the pod bay doors, please, Hal. Open the pod bay doors, please, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
And of course, it's not possible for our AI agents to control our smart devices. Or is it? I'm going to show you how I built an MCP server to allow AI agents to communicate with real-world connected devices. Now, this is just a short overview video. If you'd like more information, there's a longer video that explains step by step so you could do this yourself. And the link is in the video description. MCP server stands for Model Context Protocol. And this will allow AI agents to speak with our Matter devices. But the Matter devices require a protocol called the Matter protocol. And we're going to use some utility classes to help the MCP server communicate with our Matter devices. We're going to use the PythonMatterServer, which is a utility class provided by the Open Home Foundation. If we don't have actual Matter devices, that's okay. We're going to use a Matter virtual device, which is provided by Google. And I'll show you how to set this all up as well. We're going to be using the Google Matter virtual device to simulate our Matter devices locally. And this is a virtual device for developing and testing Matter-based devices. And it's useful if you don't have any Matter devices yourself. It has a number of devices that it's supported. So these are all the latest devices that are supported in the Matter protocol. And we're going to focus on the door lock in particular. So the instructions are on this web page about how to install it. So then what we're going to do is going to start our Matter virtual device. So in this particular video series, we're going to go and create a virtual door lock. And we're going to call this, just like in the movie, we're going to call it the Pod Bay Door Lock. So just going to type this in here. Okay, just go and create the device now. And you'll see a lot of logs happening in the background there. And if we look at the device details, we have the name of the device type, the discriminator, vendor ID, and all the things we needed. And then we have the device logs. If you look on the bottom here, it says device not commissioned. So it hasn't been connected to a Matter network just yet. So we're going to go and do that now. We're going to be using the PythonMatterServer from the Open Home Foundation, which will allow us to speak the Matter standard. It's available on this particular GitHub repository. It's officially certified as a Matter controller, and it provides a connection over WebSockets to a controller that we can use to speak the Matter protocol to our Matter devices. We'll just go over to the repo and see the command we use to run the PythonMatterServer, and this will run the PythonMatterServer in debug mode. There's another component of the PythonMatterServer which is useful. It's called a dashboard, which is a node-based web application which allows us to see the devices that are connected to our Matter fabric. And I'll cd into our dashboard, and I'm just going to run this script called script/develop. And you'll find this over on the documentation on the repo. So this will start up our node application. We go and click on this and open the dashboard. You see we have a number of nodes already. You can also use this to commission a device onto the Matter network. We need to push in a JSON structure into the WebSocket, and then we'll get a response out. We're going to run this code now. The Matter virtual device is now waiting to be commissioned. If you look at our Matter virtual device, it'll show us that the device is now commissioned. So this will enable us now to go over to our dashboard. We have 3 nodes now, and node number 11 is the new one that's been put on, and this is our door lock. So I'm going to put the Matter virtual device and the dashboard side by side here, where you can see the lock state has just gone to 2, put it back to locked, and the lock state has gone to 1 there. So I'm going to open Matter MCP server in Visual Studio Code. And you notice here the message is the same as what's in the documentation here on the PythonMatterServer GitHub repository. So we've created MCP tools for all of these individual messages that we're going to send in. And we have all the individual MCP tools ready to go here. And like I showed you, all of those MCP tools relate to the messages that we can send into the PythonMatterServer. And it's important that we put a very clear doc string in here for the MCP tools. So if I just go to README here, you can see that we have a JSON file that will be located in one of these locations depending on the operating system that you're using. And in the Claude desktop config file, you need to go and include this JSON, which basically tells Claude Desktop where to run these MCP servers. So we're going to just make sure we paste this in here and we save this, go over to run our Claude Desktop. And if you just give it just a couple of seconds for it to find the MCP tools, you'll see over here we have the MCP server. Can you unlock the pod bay door? Sending that command unlock, and it looks like it's been successful on our Matter virtual device. We're going to set this up on Claude Code. So assuming you have Claude Code installed, we're going to use the Claude MCP add, which is going to open up a guided way to set up our MCP servers. So the first thing, we're going to give it a server name. So we're going to call it the MatterMcpServer. And then we need to put in the command here. So remember, the command we're using is the UV, which you will have previously installed to get the MCP server working on Claude Desktop. So we're going to look at the Claude Desktop configuration, and this is the code we have. We used this earlier on Claude Desktop, so we're going to use this now for Claude Code. So we're going to put that in there. We don't have any environment variables, and just do confirm. So now this has already been added. So we just do finish, and then we do Claude MCP list, and that will show us that we actually have the Matter MCP server is working there. We start Claude Code, try to interact with our MCP tools. So I can ask what nodes are on my Matter network, and what it's going to do is it's going to detect that I have a MCP tool called get nodes. So that's going to return the details. So I'm going to use that one. And this has returned some JSON string there, and now currently Claude Code is looking at that, and then it pulls out indeed that I've got 3 Matter devices on my network. So I have a smart plug, a smart hub, and a door lock, which is on node 13. So I'm going to put these side by side, Claude Code on one side and the Matter virtual device on the other. So I'm going to ask it, can it tell whether it's locked or unlocked? So we're going to read the attribute, and it's read the attribute of the cluster, and it shows that it's currently locked. So we're going to go and send the device command with all the details that are there, and the door should be locked successfully. And then we can ask it to check if it is locked, and we can show that it's going to read the attribute for the right cluster, and it shows that it is locked. Claude Code had difficulty getting the right commands initially. So we're going to help the AI agent to understand the commands by using the XML data that's covered in these files that are on the Connected Home over IP repository. I've created a MCP tool which can go and tell us the commands that are available on each particular cluster. Now this is called the data model tool. So what we're going to do is we're going to add this MCP server to the Claude Code. So we're going to go into Claude Code, and if we just go and do /MCP, we can show the MCP servers, and they're all connected. The AI agent should know to go and use this to find out what commands are on particular clusters. So what it's going to do here, it's going to go and identify that it has a data model MCP to get the cluster commands. So it's going to pass in the door lock, and then all of these commands get sent back out because this is being parsed by our MCP server. And it indeed shows us that we have the locked door and unlocked door. So this really will help our MCP server to go and get it right first time when it's trying to engage with the sending commands. So we're going to just check this now, see if we can unlock the door. So it's going to get the nodes, because it has to find out what is the door lock. It doesn't know what node it's on, so it's looking for all the nodes first of all. Then it's going to go, it thinks it's on node 13, so it's going to go and get the details of node 13. And here what it does is it then is told it's found the right node, and now it's going to send the device command using cluster 257, and it's using the unlock. So now it's changed the state to unlocked, so that worked. So if you're in Claude Code and you want to find out more information about coding Matter, I have provided a lot of code labs. So I've actually gone and made a MCP server which allows Claude Code to get information. The particular command, the Python script, is called MatterCoder search. And what this is going to do is allow us to search the MatterCoder website for specific code labs. So we're going to go into Claude. So again, just check that the servers are working. We have all 3 servers working there. So let's say, how can I install the Matter SDK. It's going to call it the Connected Home over IP. It was previously called Chip on, say, Ubuntu. And I know I have another article for that, so I'll say check with MatterCoder. So let's have a check. So again, it'll do another search here, and we'll ask it, do we want to do it? And say yes. Let's pull back these articles here. And here what it's done is it's actually done a quick summary of it there. And if I click on that, you'll see here, we bring us into the particular article that we need.
We're all talking about the arrival of AI agents, but you know what's even more exciting? Getting them to control real-world devices using Matter, the new smart home standard. At MatterCoder.com, we built a hub packed with code labs and courses to train developers on Matter and AI. And with the Model Context Protocol, you can plug this knowledge directly into AI models. If this sounds like your thing, like and subscribe, and let's dive in.